So, good evening, guys. Welcome back to your session. In today's class, let me tell you what we are going to do. Probability. We are doing probability. I think today is like the last class for you all because from Monday, I think your pre-boards are starting, right? Good evening, guys. Good evening. I Oh, 1 second. Yeah. What? Oh, yeah. Yeah. So today I think will be last time before your pre-boards. So I want to tell you all the best for your pre-boards. Rocket, you have studied I think very hard in the past month. So it's time to show what you can do in this exam. Come on. So we'll be doing Bayes theorem, which is an important part of probability. So without further ado, let's get started. So before the Bayes theorem, I think the best way to we have to study total probability. So the best way to study this total probability in Bayes theorem, I think it is by learning in the question itself only. There is no separate theory which I would like to add here. According to me, it's best if we study it in the question only. So let's read and proceed very slowly. The question as there are three black and four white balls in one bag. Four black and three white balls in second bag. Okay, so let us understand the given information which is given in a way. So there are two bags, bag one, which has four, three black and four white, three black and four white, and there is bag two, which has four black and three white balls. Correct. A die is rolled and the first bag is selected if it is 1 or 3. So what is meant by this? That if on a die I get either 1 or 3, I will select the first bag. So that means probability of selecting the first bag will be probability of selecting the first bag will be 2 by 6, right? Why 2 by 6? Because either I can get 1 or I can get 3. So probability of the bag 1 getting selected is 1 by 3. So what will the probability of bag 2 being selected? It will be 2 by 3. I hope it is clear. Next, and the second bag for the right. Find the broad drawing a black ball from the selected bag. So now I want to find the probability of drawing a black ball. Correct? Now, if you understand logically, we can see that a black ball can be drawn from either of the two bags. Correct? So, if I think it as a real life case, what I'll do is, when I'll go to select a black ball, there will be two bags in front of me, right? Bag one and bag two. So first, I need to select which bag I am going to select, right? So let's say black ball, probability of black ball will be basically that I selected bag one and got black ball, or I selected bag 2 and got the black ball. So here, if you know the meaning, that is what is and usually means multiplication or usually means addition. So probability of selecting bag 1, which is 1 by 3 and getting a black ball from here. So what is the probability of getting a black ball? Total number of balls are 7. How many are black? 3 are black. So probability of getting black ball will be 3 by 7. Or probability of selecting back 2. Probability of selecting back 2 is 2 by 3. And here, from here, how many total balls are? 7. What are the black balls? 4. So getting black ball from back 2 is 4 by 7. So what I got? I got denominator में 21. Numerator में I got 3 plus 8. That means 11 by 21. That means 11 upon 21 is my answer. So what is meant by 11 upon 21, guys? 11 upon 21 is the meaning of the probability of drawing a black ball. What is the probability, or you can say total probability of drawing a black ball? It is 11 upon 21. So I hope you understood the concept of total probability. Now we will look through one more example to get it more clear, which is this. Come on. I'll let you now, as you know, you must be doing all these questions yourself. So I'll give you some time before pre-board, so you'll get like a warm-up type, correct? So yeah, I'll give you 1 minute is okay, I guess. So I'll give you 1 minute to solve this question. Come on, guys, let's see what you can do. An urn contains 7 red and 3 black balls. Okay. Urn means I told you what is meant by urn. Simply you can say it is a bag. 2 balls are drawn without replacement. Find the probability that the second ball is red if it is known that the first is red. So let's see the example. An urn has 7 red and 3 black balls. Out of this, I want to draw 2 balls. Now, the first ball that I drew was red. So, how many balls are left in the urn now? In the urn, since I draw a red ball, there are 6 red balls now remaining and 3 black balls. Now, out of this, what is the probability of drawing a red ball? So, how many total number of balls are there? 9. Out of which 6 are red, which I require. So, probability is 2 by 3. Simple. Correct. So probability is mostly very logical chapter. If you really like to play around the question, you will easily find more than one method to solve this. We are doing probability by thinking logically. I would like to say many of the times you can do probability by using PNC. But I think the PNC way is a little bit tricky in approach. So therefore we avoid. I think this is better and easy to understand. Right? PNC, yeah, 2 by 3. Manikanta, super. I looked just now. Yeah. So that what I was saying, yeah, that this logical way is much simpler, I think, because PNC as many like I also find PNC difficult sometimes. So I can think of yeah how you could find difficult because when I was in 12th standard, I did not understand PNC at all. But then again, I can understand probability. That's why I can like to think it logically. Chalo. What do we have next? Next is the Bayes theorem. So these two questions were on total probability. Now is Bayes theorem. Now Bayes theorem is just basically an extended version of total probability. What that means is, in the questions we have to find the total probability. After finding the total probability, we'll be given with a condition, or we'll be given with a result of the outcome. Uh, what I'm trying to say is, let's say, we'll see in the question, I'm saying that we have to get the total probability. But after finding total probability, there is more, and that more is called Bayes theorem. Okay, so let's look at the question here. In Bayes theorem, the outcome is already decided, or sorry, the outcome is already known. That is the main point of Bayes theorem. We know the outcome. Okay, let's see the question here. In a certain college, 25% of boys and 10% of girls are studying mathematics. The girls constitute of 60% of the total student strength. If a student is selected at random, now see, student is selected at random, and normally the question ends here. But we have been given a result that we already should know, and that result is that the student is studying mathematics. That means if I at a random I pick a student, then I don't have to worry that whether the student is studying mathematics or not. I know that that student is studying mathematics. Then we have to find a probability that the student is a girl. So such types of questions are Bayes theorem where a result is already given to us and we have to backtrace it to find the probability. I hope you can understand this. Let me simplify for you a bit. Let's say there are 100 students. Now, out of 100 students, there will be boys, girls. Let's not go into that. But out of those 100 students, there will be some section who will study maths. There will be some section who study science or whose favorite subject is maths, whose favorite subject is science, whose favorite subject is history, geography, and all. So, out of those, we already separated the students who are studying mathematics. So, that bunch of students who are studying mathematics is separate. So, we know that these students are studying mathematics. That means if I pick any student from that group, I know that I know that the student is studying mathematics. Now I want to find the probability that out of those all students, how many students are girls and how many are boys. That means what is the probability that the selected student is a girl or selected student is a boy. 2 by, you already gave the answer. I think you have prepared very well for your pre-boards. Superb. 2 by 7. Okay, let's see what we get. So, we have to find the total probability. So, which total probability we have to find? Of the probability of studying mathematics. So, let us write the given information first. Let's say we have to get the total probability of students studying mathematics. Okay. So, here, total number of girls. So, sorry. Probability of girls getting selected. So there are 60% of girls, that means 60 by 100, which is 3 by 5. So what is the probability of boys getting selected? It will be 2 by 5. Correct. Now, how many boys are studying mathematics? 25%. That means 25 by 100, which means 1 by 4. Now, how many of girls are studying mathematics? 10%. 10% means 10 by 100, which is 1 by 10. This is the given information. Now, if a student has to study mathematics, so probability that the student is studying mathematics, P of M, is one thing that he or she, or let's say she is a girl and she studies mathematics, or he is a boy and he studies mathematics. So what we are trying to do here, we are trying to get the total probability of students studying mathematics. So what is 3 by 5? into probability of girls studying mathematics 1 by 10 plus P of B 2 by 5 into 1 by 4. So I think this will be 50. 3 by 50 plus 2 ones are 2, 1 by 10. I think we have to take LCM, right? 5. 5 plus 8, 5 plus 3, 8 by 50, which is, let's use it by. So 8 by 50 is the probability of a student studying mathematics. Now, out of these, we want the student to be a girl, right? So required probability P of R, required probability that out of these, the student must be a girl. So this is the probability of that the student is a girl, and this is the probability that he or she is studying mathematics. So the required probability will be favorable, that is, the student is a girl upon total. How to read it? Let me tell you one more time. 3 by 5 are the number of girls, or you can say probability that the student is a girl and studying mathematics. And these are the total number of students studying mathematics. Please understand. Student is a girl and studying mathematics. Total students studying mathematics. So we want it should be a girl. So this will be 5 ones are 5 tens are. This will be 3 into 10 by 8, right? So 30 by 8, which is 15. Did we made a mistake here? 3 by 5. Find out that the student is a girl. So 60%, 50. Did I made a calculation error? Please see, help me, guys. Hmm. I don't think we made a calculation error. Did we? 10%, 25%. Yeah, it's right. 10 by 200 to the 5 to the 10. 2 by 5 into 1 by 4. 3 by 5 into 1 by 10. 5. 5, 6, 7, 8. 8 by 50. Hello guys, did you made a mistake or not? Find out that the student is a girl. I think there is some error in the question. Yeah, sorry, just a second. Let me check. Hmm. 2 by 5 into 1 by 4, 3 by 5 into 1 by 10. Yeah, sorry, we made a silly mistake here. Yes. The required probability is the girls should study mathematics. So that is this. Yeah. So that means 3 by 5 These are the total number of girls, and they should study mathematics upon total students that study mathematics. Right. So 50 and 50 will get cancelled, and I'll get 3 by 8. Correct. We only took 3 by 5, right? We need to take 3 by 5 is the probability of girl getting selected and she should study mathematics. So that is 3 by 5 into P of GM, it is 1 by 2. Okay, that is 3 by 8. Out of 100, 160 are girls and remaining 40 are boys. Yeah, right. So out of 100, 60 are girls. So probability of a girl getting selected is 60 by 100. Right? Yeah, it's fine. So you got 2 by 7. I checked the answer, it is 3 by 8. So what are you saying is 100% right, Rice. So is it clear, Manikantha? Should we move for next question? Okay. Let's see. Let's try one more. Now, let me tell you, many a times, I don't know how you have studied, but many a times in many books you will see that the Bayes theorem can be solved by using a tree diagram type, right? So tree diagram type is basically good for MCQ purpose because we don't have to write such theory, but you cannot use that in theory. That means in your board. Let's try one question with that tree diagram here. So let us read the question first. Yeah. 3 urns have following composition of balls. So there are 3 urns. Let's see how I draw the tree diagram, right? So this is first bag or first urn, second urn, third urn. So in the first urn, 1 white and 2 black balls. Second urn, 2 white and 1 black. And third, 2 white and 2 blacks. So 2 white and 2 blacks. Right? One of the urns is selected at random. So these are the 3 urns, guys. Out of this, one of them is selected at random. What is meant by random selection? Random selection means the probability of each of the urn getting selected is equal. That means equiprobable. So since there are 3 urns, the probability of this urn getting selected is 1 by 3. This will be 1 by 3 and this will be 1 by 6. So on the branches, make sure to write their probabilities. Now, after that, we have been given the result that the selected color is white. So we have to get the probability of getting white. From this also we have white. From this also we have white. So here, what is the probability of getting white? There are total 3, out of which white is 1. So 1 by 3. Total 3, out of which white is 2. 2 by 3. Total 4, out of which white is 2. 2 by 4. So these are the probabilities of the urns getting selected. These are the probabilities that the color white will be selected. Now, what will be the total probability, guys? Total probability is nothing but simply we have to multiply these and add all of them. So I think this is much easier in calculation for your MCQ part. We have to multiply these and add all of them. Simple. So if I multiply it, I'll get 1 by 3 into 1 by 3. 1 by 9 plus. Multiply each branch and then add all the branches. So 1 by 3 into 2 by 3. So 2 by 9 plus 1 by 3 into this is 1 by 2. So 1 by 3 into 1 by 2, 1 by 6. Right? This will be 3 by 9 plus 1 by 6. So 3 by 9 is 1 by 3. Right? Huh? 2 plus 1. 3 by 6, which is 1 by 2. Now, what is this, guys? Let me write it here. This is the total probability of getting white. Total probability of getting white. Now, out of this total probability, 3 by 11, yes. Out of this total probability, what we want? We want it came from earn 3. So, what is the probability of earn 3? Earn 3 का probability ये रहा. How do we got the probability of earn 3? Just multiply these two. So, ये दोनों को multiply किया तो अपने को 1 by 6 मिला था. So, required probability is, ये दोनों को multiply करो, 1 by 6 मिला था ना? 1 by 6. This is the probability that the white ball is selected from on 3 upon the total probability of getting white balls, which is 2 by 6, which is 1 by 3 is my correct answer. How do we got 3 by 11, Navya? Did you make some calculation error? Is this part clear first? Then you can check your answer. Please check your answer. I am 100% sure it is 1 by 3. Okay, Manikanta got it. What about Navya? Do you understood or what mistake did you made? I think the tree diagram concept is simpler. Okay, okay, super. So the required probability is 1 by 3. Ah, just a second, guys. Yeah, we did this. Ah, let's look at this. Arre, give me a second. Huh? Yeah, you read the question and try to get what I'll give you. I think 3 minutes. Try to do it with tree diagram. Okay, guys. Try to do it with the tree diagram. Come on, let's see. It's a little bit tricky question, but you can easily get it. Come on. Yes, let's see. Did you all got it? No one? Where are you stuck, guys? Let's see. How many of you all got it? Still no one. Hello. A person is known to speak truth 2 out of 3 times. He throws a die and reports it that it is 1. This might be a bit confusing, so let us simplify it. Find the probability that it is actually 1. So I think if we read just the first line, there will be 4 cases. Let's wrap up this. I think 6 cases. Okay, let's see how many cases. A person speaks truth some of the times and he lies some of the time. And he throws a die. So, what cases can be there? Case 1. The number 1 appeared and the person spoke the truth. Case 2. The number 1 appeared and the person spoke a lie. Case 3. The number 1 did not appear and the person spoke the truth. Case 4. The number 1 did not appear and the person did not spoke the truth. So out of these 4 cases we have. Let us write it. What are the 4 cases? Sorry. What is it? Yeah. Case 1. 1 appeared and he spoke truth. Second. 1 appeared and he lied. Case 3. 1 did not appear and he spoke truth. And case 4. 1 did not appear and he lied. So, we have these 4 cases, out of which case we want? He reports that it is 1. That means he says, कि हाँ, 1 आया है. So, out of these 4, which cases are we talking about? If he reports that it is 1, these are the total cases that can happen. But out of that, he reported that it is 1. So which 2 cases are left or which 2 cases are eliminated after he speaks that it is 1? Array, not a thumbs up. Which 2 cases are eliminated or which 2 cases are left which we need to study further? Case 1 and case 3. Superb. See guys, he reports that it is 1. That means 1 appear and he spoke the truth. And case 3 means 1 did not appear and he lied. No, how is case 3? Case 3, the 1 did not appear and he spoke the truth. Case 4, yes, now you are correct. Case 4, 1 did not appear and he lied. So just see that if 1 did not appear but he lied, that means he said he 1 appeared. Please get it correctly. It did not show 1 on the die, but he lied. He lied means he said ki 1 appeared, right? So we want the case where he reports that 1 appears. Now, how do we get he reports that 1 appears? 1 appears and he spoke the truth. So case 1 it is. And lastly, case 4. 1 did not appear and he lied. What is meant by he lied? He lied. That means one appeared. Got it? So we'll be talking about case 1 and case 4. So let me erase. Sorry, I think a duster would be better. Yeah. Let me erase case 2 and case 3. And I'll keep this the cases on board so you can easily understand. Right? Okay. So find the probability that it is actually 1. So now we have to find the total probability, right? So total probability that he reports 1. So these are the two cases. Now let's write the some given data here. The person speaks the truth 2 by 3 because 2 out of 3 times. That means the person tells lies is 1 by 3. What we have next? The probability that 1 will appear is 1 by 6. Obviously, na guys, if a die is thrown, then how many times 1 can appear? So probability that 1 did not appear, 1 bar, will be 5 by 6. Let us find the total probability first. Yeah. So total probability PT, total probability, will be 1 appeared and he spoke the truth. So 1 appeared and he spoke the truth. Or 1 did not appear, 1 did not appear and he lied. So P of 1 is 1 by 6 into 2 by 3 plus 5 by 6 into 1 by 3. So 6 3s are 18 and upper we have 2 plus 5, 7. So this is a total probability that the person said he 1 appeared. Out of this, what we want? Probability of required. That it is actually 1. So which case it is? Actually 1 वाला case कौन सा है? Case 1 or case 4? Come on. Actual में 1 आया. Actual में मतलब person कुछ भी बोले. But actual में 1 आया. That is case 1. Super मणिकांत. So case 1 का probability क्या है? ये रहा. Right? Which is 2 by 80. So the required upon total 18 will get cancelled. That means 2 by 7 is my answer. Good question. It was a previous year as expected. Chalo. I hope you are now very clear with Bayes theorem. Right, guys? Let's see one more question. Yeah. I'll give you 3 minutes to solve this. One for this, one for. Actually, if you got the one, the rest of them will be is the same. Let's see. Come on. 12 2 rupee coins. It is quite simple if you think. 7 1 rupee coins and 4 half rupee. We have to select 3 coins. The sum of the 3 coins is maximum. No one, it is very simple, guys. You can easily do it. Still no one. Are you all trying? Chalo. Let me explain it to you. Now, let us first write n of s. Okay. So n of s. So how many total coins are there? 12 plus 7, 19 and 4, 23. So out of 23, we need 3 coins. So n of s is 23c3. Right? 23 hai na? First one says that let it be event A. The sum of 3 coins is maximum. Now, when will be the sum of 3 coins maximum, guys? The sum of the 3 coins will be maximum when all the 3 coins are 2 rupee coins. How many 2 rupee coins are there, guys? 12. So, all the 3 coins are from the 2 rupee coin, 12c3. So, what will be probability of A? It will be 12c3 upon 23c3. I am not calculating this. Should I calculate it? 12, 11, 10 upon 23, 22, 21. So 11 ones are 11 twos are. बस ना 3 fours are 3 sevens are 2 ones are 2 twos are. बस. So I think this is 20 upon 7 161. Now, what is the second one? Let's say it is n of b. The sum of 3 coins is minimum. Now it's very simple. 3 coins will be minimum. What does that mean? That the 3 coins selected are from half a rupee. So there are 4 half rupee coin. So out of that we need 3. So 4c3. So P of B will be 4c3 upon 23c3, which is basically 4 upon 23 into 22 into 21. So I can cancel out this. Calculate it. Okay. And the last case, which is third one. Let's say it is event C, n of C. Each coin is of different value. Okay. So I need to select one coin from each. So out of 12, I'll select one. Then out of 7, I'll select one. And then out of 4, I'll select one. What will be P of C? This, which is 12 into 7 into 4 upon 23c3. So 23 into 22 into 21. अपॉन में क्या आएगा 3 into 2 into 1. Correct? So जो भी आया अभी 2 can be cancelled out with your 11. 3 sevens are 21. So this all get cancelled. 7 will get cancelled. बस ऊपर है 12 fours are 48. नीचे 23 11. 48 upon 253. This is my answer. All good, guys? Give me a thumbs up if it's clear. Acha. You were thinking it was base theorem. No, guys, it was not base theorem. Very simple question it was. Okay. So I think we'll end it here. I hope you understood the base theorem very clearly. And again, I want to wish you all the best. Please make sure you do your best, and we'll keep having the doubt difficulty sessions. If you have any doubt, also in your school, you'll have doubt difficulty session. But yeah, all the best for your pre-board. I hope you score your best, do your best. Okay, guys. Till then, bye bye, guys, everyone. Take care. All the best again. Tata. We'll meet after quite a few days, right? Almost, I think it'll be 20-30 days before we'll meet.